So in this question, we're told that the curve C has equation y is equal to 3x to the power of 4 minus 8x cubed minus 3. And in question A, part 1, we need to find the derivative of this. So we can see here that when y is equal to 3x to the power of 4 minus 8x cubed minus 3, we can then find the derivative of this, dy by dx, by multiplying 4 by 3 and then taking 1 away from the power. So that gives us 12x to the power of 3. Then we do the same for this negative 8x cubed term, which gives us negative 24x squared. And then our final term, 3, negative 3, it will differentiate to nothing. So therefore, we have that the derivative dy by dx is equal to 12x cubed minus 24x squared. Now for question A, part 2, we now need to find the second derivative of y. So we know to do this, we'll take our new derivative, dy by dx, and then differentiate it once again. So this means that d squared y over dx squared is going to be equal to 12 times 3, which is 36x squared. And then our negative 24x squared goes to negative 48x. So that means the second derivative of y is going to be equal to 36x squared minus 48x. In this question, where do we pick up our marks? So there's 3 marks available in total for part A. So our first mark will be for identifying that we need to differentiate. So going from this step to this step. Our second correct mark will be for having the correct answer for dy by dx. And then our third mark will be for correctly differentiating to find the second derivative. So there is our third mark. So moving to part B of this question, verify that C has a stationary point when x is equal to 2. So the first thing we have to note is that we have a stationary point when our derivative is equal to 0. So what we need to do is take our derivative, which we found here in question A, part 1, and sub in the value 2, and then we'll verify that if that's a stationary point by showing that dy by dx is equal to 0. So recall that our derivative, dy by dx, is equal to 12x cubed minus 24x squared. So then if we substitute 2 into this, this will give us 12 lots of 2 cubed minus 24 times 2 squared, which is going to be equal to 12 times 8 minus 24 times 4, which is equal to 0. So therefore, at x equals 2, dy by dx is equal to 0, which means that x equals 2 is a stationary point. So in this question, there was 2 marks available, and we will receive our first mark for substituting 2 into the derivative. So that is at this stage, and then we'll receive our second mark for our statement concluding the question and saying that dy by dx equals 0, so x equals 2 is a stationary point. So for part C of this question, we are asked to determine the nature of the stationary point, and we must give a reason for our answer. So our first thought is, how do we find out the nature of a stationary point? So what we need to do here is use our second derivative. So that's d squared y by dx squared. We need to use this and substitute in x equals 2 we need to substitute in x equals 2 into this, and then we will have that if d squared y over dx squared is greater than 0, then we have a minimum. And likewise, if d squared y by dx squared is less than 0, then we'll have a maximum. So without further ado, we have the knowledge that we need to do to carry out the question. So then we have that the second derivative, we recall, is 36x squared minus 48x. So therefore, we can write that out here, substituting 2 into it. Equals to 36 multiplied by 2 squared minus 48 times 2. So carrying out this calculation, we have 144 minus 96, which is equal to 48. Then we can see that 48 is clearly greater than 0, which implies that we have a stationary point, which is a minimum. So in this question, there was 2 marks available, and for that question, we'll receive 1 mark for substituting x equals 2 into our stationary point here, and then our second mark will be for the conclusion here. So in this question, we have a shape which is made up of a sector of a circle, which is joined to a sector of a different circle. So first of all, highlighted in yellow, we have the sector COD, and then highlighted in green, we have the sector AOB. So they're both from different circles. We're given a few measurements, and we're going to use this to help us solve question A, which is to find the length of OD. So I'll copy the diagram out here to make things slightly easier going forward. So we first know O to D. Since O is the center of the circle, we see that OD will be equal to the radius. Then we need to think, what other information do we have? So we have the angle here, which is 0.4 radians. And then we have the arc length is equal to 3 centimeters. So then we can put this together and make use of the formula. S is equal to r theta. S is equal to the arc length, which equals 3 centimeters in our case. R is equal to the radius. That's what we want to find out. And then we also have that theta is equal to 0.4 radians. So therefore, what we can do now is substitute these values into our equation, and that will give us that 3 is equal to r times 0.4. And upon rearranging this, we have that r is equal to 3 divided by 0.4, which is equal to 7.5 centimeters. Therefore, OD is equal to 7.5 centimeters. In this question, where do we pick up our marks? So the question is worth 2 marks. So our first mark we will pick up for using the equation S equals r theta. And then secondly, we will receive our mark for concluding with the correct answer of OD is equal to 7.5 centimeters. Now we'll move on to part B, where we're asked to find the area of the shaded sector AOB. So once again, to make things easier, we'll copy out the diagram and we'll annotate it as we go to help the question go as smoothly as possible. So first, we've been asked to find the area of a sector. So the best thing to start us off will be to write down the formula that we know for the area of the sector. So as you can see here, the area is equal to 1/2 multiplied by the radius squared multiplied by theta. So now we look at our diagram and we see we're being asked to work out the area that I'm shading in yellow here. So there's two things that stick out to me. So we know that the total length from A to D is 12 centimeters, but we know that from O to D, it's 7.5 centimeters. So we can now work out A to O by doing 12 minus 7.5. And that is going to be equal to the radius of the circle where the sector shaded in gray comes from. So therefore, R is going to be equal to A to O, which is equal to 12 minus 7.5, which is equal to 4.5 centimeters. And we can do the same for the angle as well. So we can see here that this angle in here will be the angle that we need to use as theta in our equation. And we know that these two angles will add to 180 degrees, or in this case, pi. So we have that pi is equal to theta plus 0.4, which means that theta is going to be equal to pi minus 0.4. So therefore, this means that we have the values we need and we can substitute these into our formula. So the area is going to be equal to 1 over 2 multiplied by 4.5 squared. And then we're going to multiply this by pi minus 0.4. Remembering to be careful with our brackets. And then this gives us that the area is equal to 27.8 centimeters squared. And we've got to be careful and remember our units, which are centimeters squared. So now we'll take a look and see where we picked up our marks in this question. So there's 3 marks on offer, and we will pick up our first mark for using the angle AOB being equal to pi minus 0.4. And then we pick up our second mark for using the formula area equals half of r squared theta and subbing our values in, and then we receive our third and final mark for the correct answer. So in this question, we're given a circle C, which has the equation x squared plus y squared minus 4x plus 10y is equal to k, where k is a constant. For part A of this question, we're asked to find the coordinates of the center of the circle C. So what we're going to do here is we're going to get the equation of the circle into a form where we can read the center from it. So to do this, we'll rewrite the equation, but in terms of, so we can group together the x terms and the y terms. So we'll have x squared minus 4x plus y squared plus 10y is equal to k. And then what we want to do next is we want to complete the square. So we can do that on x squared minus 4x, and we can do that on y squared plus 10y. So we can do this as follows. So we have to complete the square of x squared minus 4x. We have x minus half of that term inside the bracket. So we'll have x minus 2, then we square that, and then we subtract this value, the negative 2, we square that, and then we have that will be minus 4. And then we do the same for the y terms, which gives us, we add that on, and we have y, and half of 10 is 5, so y plus 5 squared, and then 5 squared, 25, so we subtract 25, and that is equal to k. So we could now rearrange and get this equation here into the kind of form we know it with the radius on the other side. But all we're asked to do here is to find the coordinates of the center C. So what we can do is we know we can read the coordinates from the x minus 2 and the y plus 5, those terms. So that means that the x coordinate is going to be 2 and the y coordinate is going to be -5. Always remembering we swap the signs when we go from inside the bracket to outside the bracket there. So that means the coordinates of C are going to be 2, -5. And that's us completed part A. So we can see here there was 2 marks available. So we have received our first mark for knowing to complete the square. And then our second mark is received for stating the coordinates in coordinate form or in X and Y form as done here. So in summary, the second mark is for going from the equation of the circle to the coordinates. So now we'll take a look at part B of the question, where we're asked to state the range of possible values for K. So we first must think about what is the radius. So the radius is a measurement, and we know that we cannot have a negative radius, and we know that the radius can't really be 0 either. Therefore, we know that the radius is going to be greater than 0. So now we can take a look at the equation of the circle that we started to form from part A of the question. And let us just rewrite it here, but we can tidy it up a bit. And -4, -25 is equal to -29. So the new equation of the circle will be x minus 2 squared plus y plus 5 squared -29 is equal to k. So what we can do now is add 29 to both sides, and we now have this equation, which is the equation of our circle. So we know that the radius can now be read off this part of our circle, and we know that that must be greater than or equal to 0. So we can then say that, so this now means that k plus 29 is going to be greater than 0, which means that rearranging this, k is greater than -29. So this means that we conclude that the range of possible values for k, looking back to the question, is going to be k is greater than -29. So that's our solution. We look back and we see that this question is worth 2 marks. So we will get the first mark for deducing that the right-hand side of our equation must be greater than 0. And then our second mark will be for concluding with the correct answer, k is greater than -29. So in this question, we're given that a is a positive constant, and we have an integral, t plus 1 divided by t, and we're going to integrate that with respect to t, and the limits of integration are going to be from a to 2a, and we know that this whole integral is going to be equal to ln of 7. And the question is asking us to show that a is equal to ln k, where k is a positive constant. So what we want to do is we want to start off by integrating. But we need to think about getting our integral into a form that we know how to integrate. So we're going to rewrite it. The limits stay the same, but we're going to split the terms. We're going to have t divided by t and 1 divided by t. And always remember, we're integrating with respect to t. So this is going to be equal to, our limits stay the same. We're going to have 1 plus 1 over t with respect to t. So we can now carry out the integration, and we know that 1 integrated with respect to t is going to be equal to t. And then we know that 1 over t is going to integrate to ln of t. And then what we're going to do is we're going to put square brackets around these and write our limits in to show that we have integrated, but we now just need to sub our limits in. So that's the next step. What we're going to do is we're going to sub 2a in and then subtract the expression with a substituted in. So we're going to rewrite that as 2a plus ln of 2a, and then we're going to put big brackets around it so we can keep track of our terms. Then we're going to subtract a plus ln of a. So we go back to the question and we remember that this is all equal to ln of 7 because we've done the integration. So we write that in, and then now we have to think, what do we need to do to be able to solve for a? Because that is the aim of the question. So we can try and manipulate our terms here. We can see we have lots of a's and lots of ln of a's. So we write 2a. And then we notice ln of 2a. We can use the law of logarithms. Log ab is equal to log a plus log b. So this means that ln 2 of a is going to be equal to ln of 2 plus ln of a. And then our next term is going to be a negative multiplied by the bracket, so negative a, negative ln a, and this is all equal to ln of 7. So we can now collect the like terms. So we see that we have a 2a and a negative a. So we combine them, we have a, and then our ln 2, that will stay, but we've got a plus ln a and a minus ln a, which will leave us with ln 2, and we recall that that is equal to ln of 7. So then our next stage is going to be to solve for a, so we subtract ln of 2 from both sides. And this is going to leave us with ln of 7 minus ln of 2. And then we can now use the law of logarithms again. Recall that log a minus log b is equal to log a over b. So this means we can rewrite ln of 7 minus ln of 2 as ln of 7 divided by 2. So this now looks quite like what we're aiming for. So a is equal to ln 7 over 2. And we can rewrite this as a is equal to ln of k, where k is equal to 7 over 2. So this is us reached the end goal. We've solved the constant k. So now we're going to take a look back. This question was worth 4 marks. So where did we get our marks? So we got our first mark for attempting to divide each term by t. So you can see here, when we went from t plus 1 over t to 1 plus 1 over t, that was us receiving our first mark. We then received our second mark for knowing how to integrate. So for going from 1 plus 1 over t, integrating that to getting t plus ln of t. So we then got our third mark for knowing to substitute a and 2a into our expression. So this was substituting our values into the limits and then making it equal to ln of 7. Then finally, our fourth mark came from the rest of the working, all the algebraic manipulation of the expression to come to the conclusion that a is equal to ln of 7 over 2.
So in this question, a curve C has parametric equations x is equal to 2t minus 1 and y is equal to 4t minus 7 plus 3 over t. And we know also that t will not be equal to 0. So we're being asked to show that the Cartesian equation of the curve C, so this equation here, can be written in the following form, with y being equal to 2x squared plus ax plus b divided by x plus 1. So a and b, they're both integers, and we need to get these two equations into this form, and then we'll find out what a and b are. So the first step, we've got our equations written out here, and what I'm going to do first is I'm going to rearrange this expression for x, but this time get it in terms of t. So we'll write that as x plus 1 is equal to 2t, and then to isolate this t on its own, what we're going to do is divide by 2. So that means that t is equal to x plus 1 divided by 2. The next step is going to be to substitute this expression for t into this equation for y. So how do we know to do this? Well, our end goal is something which is in terms of x, and it's going to be equal to y. So we see we have y here, and we have t's here, but we know that we also have something which is t, which is equal to something in terms of x. So if we substitute this into this equation here, that will then mean we have an expression for y in terms of x. So we can do that as follows. Y is going to be equal to 4 lots of x plus 1 over 2. Then we're going to subtract 7. And then we have then 3 over t. So that will be 3 over x plus 1 over 2. And since we're dividing by a fraction, we can multiply it but flip it. So that will be then equal to 3 times 2 over x plus 1. So the 3 times 2 comes from the fact we have 3 there and 2 there. So the next step from here will be to expand out the brackets. So we'll have that y is equal to 4 lots of x plus 1 divided by 2 minus 7 plus 6 divided by x plus 1. So then the next step will be to further tidy this up. So we see here that this 4 and 2 will cancel out and leave us with 2 lots of x plus 1. So we can expand those brackets further, which will be 2x plus 2. Then we subtract our 7. And then this final term stays as it is for just now. So then we can collect these like terms here, which will leave us with y being equal to 2x. Then 2 take away 7 is going to be minus 5. Then we're going to add on 6 over x plus 1 to that. So the next step for us is going to be to combine these into one single fraction. So we can do this as follows. So let's just put brackets around our 2x minus 5 just to make things slightly clearer. So then what we're going to have, we can effectively think of this as 2x minus 5 divided by 1. So we can use our kiss and smile technique, which is how we know to add fractions. So this is where we go multiply, multiply, and then multiply along the bottom. So what does this give us? Well, it gives us 2x minus 5 multiplied by x plus 1. Then we're going to add on 1 multiplied by 6, which is going to be equal to 6. And then we divide this by the denominators multiplying each other, which is going to be equal to x plus 1. So the next step is going to be to tidy up this numerator and get it into the form that we want. So we can expand these brackets. And by doing this, we'll have 2x squared. And then we're going to have, I'll just write it at the side just for quickness. So we'll have 2x coming from this term, and then we'll have minus 5x from that term. So 2x minus 5x is going to be equal to minus 3x. So we can then substitute that back in here. So that will be 2x minus 3x. And then our final term will be minus 5 multiplied by 1, which is going to be minus 5. Then we add on 6 from this final term. And then we still divide that by x plus 1. And then tidying this up, we have minus 5 plus 6, that is going to be equal to 1. So we then have 2x squared minus 3x plus 1 divided by x plus 1. So now we look back to the question and we recall that we wanted to get get our expression into the form y is equal to 2x squared plus ax plus b divided by x plus 1. Then looking back to our answer, we see we have it in just that form. So we can conclude that y is equal to 2x squared minus 3x plus 1 all divided by x plus 1. And then we can also state the values of a and b. So a is going to be equal to minus 3 and b is going to be equal to 1. And that is us. We have completed the question. So we're now going to take a look and see where we picked up our marks. So looking back at the question, this was worth 3 marks. So we pick up our first mark for attempting to substitute t equal to x plus 1 divided by 2. We pick up our first mark for trying to substitute that into our expression for y. So that's 1 mark we've picked up. We'll then receive our second mark for multiplying our fraction out to get it into one single fraction. So when we go from this point here through to this point here, that is where we'll pick up our second mark. And then our third and final mark, it is going to come from coming to the correct answer here, where we said that y is equal to 2x squared minus 3x plus 1, all divided by x plus 1. So in this question, we're given quite a lot of information. So let's just take a minute to work through the information we're given, and then we'll look at the question and see what we need to do. So we're told that a company plans to extract oil from an oil field. We're told that the daily volume of oil, which is denoted by V, is measured in barrels, and the amount of oil that is extracted from the oil field depends upon the time, which is denoted by T, and it's measured in years, and it will be measured from after the start of the drilling. The company decides to use a model to estimate the daily volume of oil that will be extracted from the oil field. And there are a few bullet points here with assumptions that the model accounts for. So we're told that the initial daily volume of oil extracted from the oil field will be 16,000 barrels. So this means that when T is equal to 0, there will be 16,000 barrels of oil being extracted. The daily volume of oil that will be extracted exactly 4 years after the start of the drilling will be 9,000 barrels. And we're told that the daily volume of oil extracted over time will decrease. And this makes sense because we know that oil is a finite source which will eventually run out. So we're now shown 2 models, Model A and Model B, and these are both 2 possible ways of modelling the situation. So we can see, having a quick look at Model A, we can see that it is a straight line. So then looking at Model B here, we can see there is a curved fitted line there. So now we're going to take a look at what the question is asking us to do. So question A part 1. Use Model A to estimate the daily volume of oil that will be extracted exactly 3 years after the start of the drilling. So now taking a look back at our graph, we can see that at this point here, T is equal to 4. So we know that T equal to 3 will be roughly around here, around this point here. So I think the best way to work this out will be to calculate the gradient. So we know that we can work out the gradient as follows. So the gradient is going to be equal to the change in y coordinates divided by the change in x coordinates. So we can work this out by doing 9,000 minus 16,000, and we divide this by the change in x coordinates, which is going to be 4 minus 0, which is 4. So overall, putting this into our calculator, it comes out the gradient is negative 1,750. And then we already know that, looking back at the question, that 16,000 is the y-intercept. So we can actually just write the equation of the line out. So we have that y is equal to 16,000 minus 750x. But then we must remember that we're not dealing with x's and y's, we're dealing with v's and t's. So really our equation should be v is equal to 16,000 minus 1,750t. So then, recalling our question, we're asked to use Model A to estimate the daily volume of oil that will be extracted exactly after 3 years. So this means that we can plug 3 into our equation with t, and then we will have that the volume is equal to 16,000 minus 7,050 multiplied by 3, which is equal to 10,750 barrels. Now for question A part 2, we're asked to write down a limitation of using Model A. So one thing that you may notice, we have our equation, v is equal to 16,000 minus 1,750t. So we're going to have a look at what happens when t is equal to 10. So we can find this out by substituting t equals 10 into our equation. So we have 16,000 minus 1,750 times by 10. But we see that this is equal to negative 1,500. But this isn't possible because we can't have negative amounts of oil. So this is impossible. So therefore we conclude that a limitation of the model is that it doesn't actually work, and it gives us an unrealistic value for the oil extracted after 10 years. So now we'll take a look at question B, part 1. So we're asked, using an exponential model and the information given in the question, find a possible equation for model B. So when we see exponential model, the first thing we must think of is kind of our standard equation. And it's always going to be y is equal to a e k to the power of t, where a and k are both constants. So we need to convert this into something that looks more like the notation we've been using throughout our question, where y is equal to v and t remains as t. So we therefore have this. V is going to be equal to ae k to the power of t. And what we now need to do is we need to work out the constants a and k, and then this will give us the equation for model B. So using the information we were given in the question, we know that when t equals 0, v is going to be equal to 16,000. So then we can substitute these values into our equation here, and we'll have that 16,000 is equal to ae to the power of k times 0. And we know that e to the power of 0 is going to equal 1. So that means we have that 16,000 is going to be equal to a. So then we can use the next data point we know, which is when t is equal to 4, v is going to be equal to 9,000. And this means that we can then do the same again by substituting our values in, and this time also use our newfound a is equal to 16,000. So we have that 9,000 is equal to 16,000 multiplied by e to the power of 4k. So the next thing we need to do is we have all we need in this equation here, and we just need to rearrange to solve for k. So we can initially divide both sides by 16,000, and we then have that 9,000 divided by 16,000 is going to simplify down to 9 over 16. So this means we then have, just swapping the sides to make things look a bit nicer, E4k is going to be equal to 9 over 16. So the next step is to get rid of the exponential here and to get, isolate k on its own. And we can do this by taking ln of both sides. So this is going to equal, so remember ln of an exponential is going to equal the power of the exponential. So I have that 4k is equal to ln 9 over 16. And then now we can simply isolate k on its own by dividing both sides by 4. So k is going to be equal to 1 over 4 ln 9 over 16. So we now look back at the question. What were we being asked to do? So we were asked to find an equation for model B. So we've now worked out what k is, and we've worked out what a is, and we know what our equation is. So we can simply write out our equation. So v is going to be equal to 16,000, then e to the power of k, which is going to be 1 over 4 ln 9 over 16. Then we're going to multiply that by t. And there we have the equation of model B. V is equal to 16,000 e to the power of 1 over 4 ln 9 over 16 multiplied by t. Now taking a look at question B part 2, we are asked to use our answer from B part 1, so this equation here, to estimate the daily volume of oil that will be extracted exactly 3 years after the start of the drilling. So how will we do this? We will simply take our equation here and substitute in with t being equal to 3, and that will give us our value. So the volume of oil is going to be 16,000 multiplied by e to the power of 1 over 4 ln 9 over 16 multiplied by 3, and putting that into our calculators, we get that the volume of oil is going to be equal to 10,392 point blah blah blah, and then we'll round to 3 significant figures, so that's why we don't need to know what's after the decimal point, and this comes out as 10,400 barrels. So this means that after 3 years, they will have extracted 10,400 barrels of oil. Now that we've completed the question, we're going to take a look back and see where we picked up our marks. So question A part 1 and A part 2, this combined was worth 2 marks. So in question A part 1, we receive our mark for concluding with the correct answer, which was 10,750 barrels of oil. Then again, for question A part 2, we receive 1 correct answer for writing down 1 limitation of the model. So now we'll take a look at where the marks were on offer for part B. So there's 5 marks on offer in total. So taking a look at part 1 of the question, we received our first mark for suggesting a suitable exponential model. So this is where we wrote that v was equal to aek to the power of t. We then received our second mark for knowing to use the values we were given in the question to work out what a and k were. And then the next mark was for successfully working out the value of k. And then the final 4th mark was for concluding with the correct answer. Then there was 1 mark on offer for question B part 2, which was for knowing to substitute 3 in and concluding with our correct answer. So in this question, we're given a diagram, figure 2, and this shows a sketch of a triangle with vertices A, B and C. So we're given some information. We're given what vector A to B is, and we're given what vector B to C is. And what we're asked to do, we're to show that the angle BAC is equal to 105.9 degrees. So to begin this question, I'm going to copy out the diagram down here, And then what we're going to do is we're going to annotate it with the information we know. So we're given that AB is 2I plus 3j plus k. So we're going to annotate this on our diagram. So we know that A to B is going to be this side here. So let us write our vector in there. So we have 2, 3 and 1. And we know that that is AB. And that will be going in this direction here. And then similarly for B to C, we know that it is 1 minus 9, 3. So we'll write that in here. So we're going from B to C. So that's going to be 1 minus 9 and 3. And that is going to be B to C. And we know that that will be in this direction. So we now need to look at what we're being asked. So we're being asked for the angle BAC. So we know that that is going to be the angle at the vertex A. So we can just draw this into our diagram here that we're looking to find this angle here, and let's denote it theta. So what we need to do now is we need to figure out what this length is here. We need to figure out AC. And then we'll be able to use this to calculate what the angle is. So we know that we need to find what A to C is. And we know that if we go from A to B and then go from B to C, this is the same as doing A to C. So therefore, we can work out AC as follows. A to C is going to be equal to AB plus BC. So then what we can do is we can just simply write our column vectors as follows. So 2, 3, 1 plus 1 minus 9 and 3. And this gives us what A to C is. And that comes out as 3 minus 6, 4. So therefore we can take this and annotate it onto our diagram. So that means that we have 3 minus 6, 4. So our next step now is to think of a formula that we know which helps connect us with angles and vectors. So this formula is as follows. Cos theta is going to be equal to the dot product of A and B, and we're going to divide that by the magnitude of A multiplied by the magnitude of B. So in our case, we know that our vector A is going to be AB and our vector B is going to be AC. So let's just write this down for completeness. So let A be equal to 2, 3 and 1 and B be equal to 3 minus 6, 4. So we do note that we need both vectors to be pointing away from the angle. So we have this here. AB is going in the direction away from where the angle is, and AC is also going in the direction away from where the angle is. So what this means is we can now work out what the magnitude of A and B are. So we do that as follows. The magnitude of A is going to be equal to 2 squared plus 3 squared plus 1 squared. And we square root that, and that is going to be equal to the square root of 14. And likewise, the magnitude of B is going to be equal to 3 squared plus minus 6 squared plus 4 squared. And we square root all of that, and that comes out as the square root of 61. And then we can also work out the dot product of A and B, and we do this by multiplying each term and adding them. So A dot B is going to be equal to 2 times 3 plus 3 times minus 6 plus 1 times 4, and then that is going to be equal to 6 minus 18 plus 4, which is equal to minus 8. So now we have all the values that we need, so we can make use of our formula here. So just for completeness, I'm going to highlight all the values we're going to use in our formula. So we now have -8, which is going to be the dot product of A and B, and then we have the magnitude of A and the magnitude of B. So then, taking a look at our formula, we know that cos of theta is going to be equal to -8 divided by root 14 times by root 61. We then have that theta is going to be equal to cos to the -1 of -8 over root 14 times root 61. So then we can put this into our calculators and we'll get that theta is equal to 105.887, and then rounding to one decimal place, we conclude that theta is going to be equal to 105.9 degrees, which then, looking back to the question, we were asked to show that the angle is equal to 105.9 degrees, so we can write a conclusion. Therefore, the angle BAC is equal to 105.9 degrees as required. So we'll now go back and take a look at where the marks run off in this question. So we can first see that there was 5 marks available for this question. So our first mark comes from knowing to calculate the next length AC. So when we calculated 3, -64, we received our first mark. We then receive our second mark for knowing to use the formula cos theta is equal to AB divided by the magnitude of A multiplied by the magnitude of B. That's where we receive our second mark. We'll receive our third mark for knowing to then calculate the magnitudes. So there we've calculated the magnitude of A and the magnitude of B. We receive our fourth mark for working out the dot product, and we then receive our final and fifth mark for knowing to substitute these values into the formula and concluding with the correct answer. So in this question, we're given a function, f of x, which is equal to ln of 2x minus 5 plus 2x squared minus 30. And we have the condition that x must be greater than 2.5. Question part A. So we're being asked to show that f of x equals 0 has a root alpha in the interval 3.5 to 4. So how are we going to do this? So what we can do is we can show that if there's a change in sign within the interval 3.5 and 4, then we know that there will be a root at f of x equals 0. Let's take f of 3.5, which is the start point of our interval. So what we do ln of 2 times 3.5 minus 5 plus 2 lots of 3.5 squared minus 30. So then if we put this into our calculator, it comes out at negative 4.81. So if we then take the end point of our interval, which recall is 4, we'll then have f of 4 is going to be equal to ln of 2 times 4 minus 5. So we're not going to write this out again, but we'll put this into our calculator, and it comes out that f of 4 is equal to 3.10. So we have negative 4.81 and positive 3.10. So therefore, in the interval, so we're working on the interval 3.5 to 4, we see a change in sign, and this means that there is a root within this interval, and we denote this root alpha, and therefore we have completed part A of the question. So now moving on to part B, we're given some further information. So we're told that a student takes 4 as the first approximation to the root alpha. So we're then given that f of 4 is equal to 3.099, and the derivative of this, we then plug 4 into that, and we have that f-4 is equal to 16.67. So in part B, we're asked to apply the Newton-Raphson procedure once to obtain a second approximation for alpha, and we're asked to give our answer to 3 significant figures. So our first thing to recall is, what is the Newton-Raphson formula? So you may remember that the Newton-Raphson formula is going to be x of n plus 1 is going to be equal to x of n, so our starting point, and we subtract f of x of n, and we divide that by f dash x of n. So this is important. This is the formula which we're going to use. So we then recall what information we're given. So we're given that xn is equal to 4. So this is our starting point. We're then given that f of 4 is equal to 3.099. And then f dash of 4 is equal to 16.67. So this then means we can take these values, which were given in the question, and substitute these into our formula to work out what x of n plus 1 is going to be equal to. So therefore, x of n plus 1 is going to be equal to 4, and then we take away 3.099, and we divide that by 16.67. And putting these numbers into our calculator, it comes out with 3.81409. Then there are some further decimal places, but that's all we're going to need to conclude to 3 significant figures. So then rounding this to 3 significant figures, we have that x of n plus 1 is going to be equal to 3.81. So now for part C. So what do we have here? So we're asked to show that alpha is the only root of f of x equals to 0. So this is a slightly trickier question. So to start off, we're going to set f of x equal to 0. So f of x equals 0. So then this means that ln of 2x minus 5 plus 2x squared minus 30 is going to be equal to 0. So what we can now do is we can rearrange this so we have each x term on either side of the equality. So this leaves us with ln of 2x minus 5 is going to be equal to 30 take away 2x squared. So this is now our equation that we want to work with. So we know that these two terms have to be equal. So what we can do is we can sketch the graphs of these two equations and then look and see at how many points of intersection there is. So now I've drawn some axes, we can take a look and have a think about how to sketch these things. So let's first take 30 minus 2x squared. So we know that this is going to be a parabola shape, and it's going to be a negative parabola because of the negative in front of the x term. And because we're only sketching the graph here, the exact specifics don't matter too much. So what we can do is we can draw in our parabola. So here we have, it'll take this sort of shape here. So that's a good starting point, and it's we can see the shape of our graph. So then we can now, I'm going to do this in green so we can see the difference. We can now draw in ln of 2x minus 5. So it's going to look something like this. It's going to increase up, cross the axis, and then turn like that. So now, what do we notice? Well, there's only one point of intersection between these two graphs. So what this means is that we can conclude that they meet in one place, so there's therefore one root. So we'll just write this down. One point of intersection. And what this means is that there is only going to be one root. So that means that alpha is the only root. And therefore we have finished the question. So now we're going to take a look back and see where the marks were on offer. So part A, where we had to show that there was a root in between 3.5 and 4. It was worth 2 marks. So we received our first mark for calculating f of 3.5 and f of 4. And then we received our second mark for knowing that a change in the sign results in there being a root in this interval. Then for part B, it was worth 2 marks also. So we receive our first mark for both knowing the Newton-Raphson formula and substituting our values in. So stating the formula, substituting our values in, that gives us 1 mark, and then we receive our second mark for concluding correctly that x of n plus 1 was equal to 3.81. We then move to question part C, which was worth 2 marks. So we receive our first mark for attempting to sketch both the drawings. So we receive that mark for a sketch here, and then we receive our second mark for our little conclusion where we stated about there only being one point of intersection, and that meaning alpha is the only root. So in this question, we've been asked to prove that tan theta plus cot theta is equivalent to 2 cosec 2 theta. So what we're going to do is we're going to work through this together and look at all the different stages we need and all the different trig formula that we need to be able to prove this. So we need to have a think about what terms we have and what we know about them and how we can rewrite them. So whenever we see a tan theta, we always know that a good way to rewrite this is going to be tan theta is equal to sine theta divided by cos theta. And then in terms of our second term here, we know that cot theta is going to be 1 over tan theta. So I'll just write this here as well. So we have that cot theta is equal to 1 divided by tan theta. But then we have just written that tan theta is equal to sine theta over cos theta. So then that means we can actually rewrite cot of theta in terms of sine and cos, but this time it's 1 over tan theta, so we flip this fraction here, so cot theta is actually equal to cos theta, and we divide that by sine theta. So our next step will be to take these new terms here and substitute them into kind of our original equation so we can make progress towards this proof. So we'll continue down with the equivalent lines, so we will just move over to the side slightly. So we'll have that tan theta plus cot theta is going to be equivalent to sine theta, and we divide that by cos theta, and then we are going to add on cos theta divided by sine theta. And then I think the next best step from here would be to make these into a single fraction. So to do that, we need to add them together. Sine squared theta plus cos squared theta. And we divide that all by sine theta cos theta. So we now have a single fraction which we can deal with. So our next thoughts are, what do we know about these terms? So the first thing that springs to mind is sine squared theta plus cos squared theta. So we know that we have we know the following trig identity, that sine squared theta plus cos squared theta is going to be equal to 1. So this is really good because 1 is a lot, it means the same thing, but it is a lot simpler to look at, and it is in the direction we want to go. So therefore it's great that we'll now be able to substitute 1 into our equation. We also take a look and we think sine theta, cos theta. How does that look familiar? So you may think of the double angle formula, but the double angle formula, as you'll remember, is written as follows. Sine 2 theta is equal to 2 sine theta cos theta. You can see this is good. This looks similar to what we have. We have sine theta cos theta, and here there is sine theta cos theta. But unfortunately, the double angle formula has a 2 in front of it. So we now think, what can we do to manipulate this to get it into the form we require? So what we can do is we can divide by 2. So if we divide both by 2, that's the same as multiplying by half. And then we see here that 2 will go and that will go, which that means that a half sine 2 theta is equal to sine theta cos theta. And that's exactly what we have here. So this means that we can continue with our replacement into the expression we have. So we'll then have 1 as our numerator, and our denominator is now going to be this here, 1/2 of sine 2 theta. 1/2 of sine 2 theta. So we know that dividing by a half is going to be the same as multiplying by 2. So this is going to be equivalent to 2 divided by sine 2 theta. And then finally, we'll go back and have a look at the aim of the question. So we were looking to write it in terms of cosec 2 theta, and we now have 2 over sine 2 theta. So we need to think, what other trig formula do we know that will take us to the next stage? So we do know that cosec 2 of theta is equivalent to 1 over sine 2 theta. And this is exactly what we need. We can now substitute this in, and we'll have that is equivalent to 2 cosec 2 theta. And then we'll just double check what we were looking for again. So here we can see in the question 2 cosec 2 theta, and we have 2 cosec 2 theta. So then we can just write a concluding statement such that tan of theta plus cot of theta is going to be equivalent to 2 cosec 2 theta as required. So now we've completed the proof. So we will now move on to part B of this question. We are asked to explain why the equation tan theta plus cot theta equal to 1 does not have any real solutions. So we recall from question 1 that tan theta plus cot theta is going to be equivalent to 2 cosec 2 of theta. And we recall, going back one step previously, that this was equivalent to 2 divided by sine 2 theta. And we're being told that this is going to be equal to 1. So what we now need to do is we need to rearrange this here and then have a look and see why there may not be any real solutions. So we can multiply both sides by sine 2 theta, which will give us that sine 2 theta is equal to 2. So now we're thinking, right, this is great. So we can then work out 2 theta is equal to sine minus 1 of 2. But we have a problem. we can't do this because no solution exists. So we need to think, why does no solution exist? So I've drawn some axes here. So let me now sketch out what sine of 2 theta may look like. So very roughly, it'll take this sort of shape. And we know that sine has a magnitude of 1 and then -1 on the lower y-axis. But our issue here is that 2 is greater than 1. So we know that sine is only going to be defined for -1 greater than or equal to sine 2 theta greater than or equal to 1. But we're looking for it being equal to 2. But we know this will never happen because 2 is greater than 1. So since 2 is greater than 1, the 2 is out with the range of the sine 2 theta. So this means that no solution exists. So we've now completed the question, and we're now going to take a look back to see where we picked up our marks. So looking back at question part A, it was worth 4 marks. So we received our first mark for going from the original equation down to this step here. So when we knew that tan theta was equal to sine theta over cos theta, and we knew that cot theta was equal to cos theta over sine theta. That's where we achieved our first mark. We then received our second mark for multiplying out our fraction and making it into one single fraction here. We then received our third mark for knowing that sine squared theta plus cos squared theta was equal to 1, and also using the double angle formula here. So we achieved our third mark at this stage here, and we then achieved our fourth mark for knowing that cosec 2 theta was equal to 1 over sine 2 theta, which then led us on to the correct answer where we picked up our fourth mark. Now for question B, it was worth 1 mark. And we achieved this mark for coming to the conclusion that sine 2 theta only runs between 1 and -1, and therefore no solution exists. So in this question, we're given that theta is measured in radians, and we're being asked to prove from first principles that the derivative of sine theta is equal to cos theta. And we're given some information which we can use to do with what happens to certain things as h tends to 0. So to begin, we'll have to have a think about what the definition of the derivative is. So we know that the derivative f dash x is going to be equal to the limit as h goes towards 0 of f of x plus h minus f of x, and we divide this by h. So this is going to be very useful in this question, and this is known as the definition of the derivative. In our case, we're going to be dealing with theta rather than x, so we now need to think, what is our function f of theta? We know that we want to differentiate sine of theta, so that means that f of theta is going to be equal to sine theta. We have f of theta effectively, which is this f of x here, and we now need to find what f of theta plus h is. So we have as follows: f of theta plus h is going to be equal to sine, then we'll put brackets in this time, of theta plus h. So we can now expand sine theta plus h by using the compound angle identity. So we know that the compound angle identity is as follows. It is going to be sine of theta plus h is going to be equal to sine theta cos h plus sine of h cos of theta. So we now have all the information that's required to then substitute this into the definition of the derivative. So this means we'll have that f dash theta is going to be equal to the limit as h tends to 0 of sine theta cos h. We're going to then add sine h cos of theta. And then we now need to subtract our f of theta term, which is going to be sine theta. So we take away sine theta. And then we divide all of this by h. So then our next step is to get this into a form where we can take the limit easily. This is not easy to do at this point because we've got lots of h's, some are in the numerator, and we've got one in the denominator as well. So what we can do is take some common factors out. So we'll rewrite our first part. So f dash of theta is going to be equal to the limit as h tends to 0. So now let's have a look and see what we can do. So we have a sine theta here and a sine theta here. So what we can do is take a common factor of sine theta out. So we'll have sine theta, and then to get this sine theta, we'll multiply by cos of h, and to get to this sine theta, we'll multiply by -1. So that means we'll have sine theta multiplied by cos of h, subtract 1, and we divide this by h. And we then add this and have a look at what we have remaining. So we'll have this in here, so we'll have sine h cos theta over h. So we'll rewrite this as sine of h all divided by h, and we multiply that by cos of theta. So then we'll just take a look back at the question and have a look at the information that we are given. So we're given here that as h tends to 0, sine h over h tends to 1, and as h tends to 0, cos h minus 1 divided by h tends to 0. So we'll now take a look and see how this relates to what we have. So we can see here that we have cos of h minus 1 divided by h, and we know that this here, that is going to tend to 0, and we know that sine h over h is going to tend to 1. So this leaves us with the following. We have that f dash theta is going to be equal to sine theta multiplied by 0. Then we're going to add on 1 multiplied by cos theta, which is going to be equal to cos theta. Therefore, we conclude that f dash theta, so the derivative of sine theta, is going to be equal to cos theta, as required. So this question was worth 5 marks. So we receive our first mark for knowing this formula here, for knowing that the definition of the derivative. We then receive our second mark for using the compound angle identity and expanding sine theta plus h. We then receive our third mark for doing the expansion and getting it into this form here, into a single fraction. And we then receive the fourth mark for identifying the common factors, and then we receive our fifth mark for taking these limits here and following through to get to the required answer that f dash theta is equal to cos theta. So in this question we're given the following information. We're told that an archer shoots an arrow, and the height, which is denoted by h and measured in meters, of the arrow above the ground is modelled by a given formula. So we're told that h is going to be equal to 1.8 plus 0.4d minus 0.002d squared, where d is the horizontal distance of the arrow from the archer, and this is also measured in meters, and we're told that d is greater than or equal to 0, which makes sense thinking about it in the real world, as distance must always be greater than or equal to 0. So we'll now take a look at part A of the question. So we're told that the arrow travels in a vertical plane until it hits the ground, and we're asked to find the horizontal distance travelled by the arrow given this model. So we have our equation here, h is equal to 1.8 plus 0.4d minus 0.002d squared. And we're told that the arrow is going to hit the ground. We recall that the horizontal distance is the height from the ground, and therefore when it hits the ground, we'll have that h is equal to 0. So therefore, we'll have the following equation, taking this down from here, and we can say that negative 0.002 d squared plus 0.4d plus 1.8 is going to be equal to 0. We can then solve this equation here and find out what d is. So we can't factor this out because it's slightly trickier numbers. So what we can do is make use of the quadratic formula. So we recall that the quadratic formula is an equation that we can use to work out the roots and the solutions of a quadratic function like this. And we know that it is going to be negative b plus or minus b squared minus 4ac, and we divide all of that by 2a. So we now need to think, what are a, b, and c going to be? So we know that a is going to be the coefficient of the d squared term, so that's going to be negative 0.002. We know that b is going to be the coefficient from the d term, so 0.4, and then finally c is going to be equal to 1.8. So we can then take these values and substitute them into our quadratic formula. So we have negative 0.4 plus or minus, then we'll put the square root in at the end, so we'll have 0.4, and we square that, and we subtract 4 lots of negative 0.002, and we multiply that by 1.8, and then like I said, we need to remember to take the square root of it, just like this, and then we divide that by 2a, and we know that a is negative 0.002. So we put these into our calculator, and we have both the positive square root and the negative square root. So we'll get two solutions. So we'll have a positive solution and we'll have a negative solution. So these are d is equal to negative 4.403, and for the negative of the square root term we have 204.403. However, we know that the solution, which is d is equal to negative 4.403, that can't be a solution. That's not a valid solution because d must be greater than 0. So we'll just put in not valid since d is less than 0. So therefore we conclude that the answer is going to be that d is equal to 204 meters. Now moving on to part B of this question, we're asked, with reference to the model, so that means taking a look at the equation that we're given in the certain circumstances, we're to interpret the significance of the constant 1.8 in the formula. So let's recall that our formula is h is equal to 1.8 plus 0.4d minus 0.002d squared. So we can see from the model that 1.8 is the only part of the equation which doesn't have a d variable as part of it. And this means that when d is equal to 0, we'll have that h is equal to 1.8. So we can therefore conclude that 1.8 is the initial height of the arrow above the ground. So we'll now take a look at part C of the question, where we're asked to write our equation for h, and we're asked to write that in the form here, a minus b multiplied by d minus c squared, where a, b, and c are all constants which we need to find. So the first step we need to do here is have a look and think about, is there anything that looks familiar for this equation a minus b, d minus c squared? So one thing that comes to my mind is d minus c squared with a constant on the end. This this reminds me of completing the square. So we'll just note here that this looks like completing the square. But we do note that this isn't yet in a form which would be entirely easy to complete the square. So what we're going to do is we're going to rewrite it. And we're going to rewrite it as follows. We're going to take a common factor out of negative 0.002. So we'll then have the following. We'll have negative 0.002, and then we're going to multiply that by d squared minus 200d, and then we'll have our 1.8 on the end. So as you can see here, we've taken out a common factor of negative 0.02, and then it leaves us inside the brackets here, d squared minus 200d. So then what we can now do, this term inside the bracket here, this is now in the form that we know that we can complete the square. So if we just go over to the side here to complete the square, we know this will be d minus, we have half of negative 200, which is going to be negative 100. And then we have around the brackets, we're going to have that squared. And then we'll subtract 100 squared, which is 10,000. So that's us completing the square of this term here. So what we can then do, and we'll need to be careful with brackets to make sure we're keeping track of where our brackets are and what's being multiplied by what. So we'll keep our negative 0.002 on the outside, and then this whole term can be replaced with this term here. So we'll bear in mind we're going to put in big brackets like this just to make things easier. So then in there we'll have d minus 100, then we'll have small brackets round that, and then we'll take away 10,000. And then we'll close our big brackets, and then we add on our constant from the end there of 1.8. So then the next step for us is going to be to multiply out these brackets. So we'll first have negative 0.02 multiplied by our d minus 100 squared. So that will give us negative 0.002 d minus 100 squared. And then we're going to have negative 0.002 multiplied by negative 10,000, which comes out as positive 20. And then that's us finished with the big brackets. So we then have our constant 1.8 on the end. So we plus 1.8. And then tidying this up, so all we need to do is simplify this by combining these two terms here. So 20 add 1.8. This then leaves us with negative 0.002 lots of d minus 100 squared plus 21.8. So therefore, looking back at our question, we have a constant a, and then we have b here multiplied by the bracket, and then we have c inside the bracket. So we can draw the following conclusions such that a is going to be equal to 21.8. We then have that b is going to be equal to the number in front of the bracket. So that's going to be 0.002, and then we'll finally have that c is equal to 100. So therefore we conclude that a is equal to 21.8, b is equal to 0.002, and c is equal to 100. So now taking a look at part D of this question, we're given some further information. So we're told that we have a new model, and the formula for this is going to be h is equal to 2.1 plus 0.4d minus 0.002d squared. And we're asked to find the maximum height of the arrow above the ground. So we have our new model, but we're first going to take a look at our previous model, which is written out in purple here. So we can see the only difference between the new model and the old model is our constant. We now have 2.1 as opposed to 1.8 from before. And from our knowledge of parabolas, we know that for the previous model and the current model, we're going to have a parabola which is shaped like this. So it's going to be a sad face parabola, since the coefficient in front of the squared term is negative. So as you can see here, this will be the shape of a parabola. So we know from the shape of our parabola and our knowledge of parabolas that the maximum height of the arrow above the ground is going to be the turning point of our parabola. So we can then take the square form, which we have here, bear in mind this is the old model, and we can read off the coordinates of our turning point. So for this old model, the turning point is going to be 100 and the y coordinate is going to be 21.8 because we read from here and we flip the sign of this one. So the turning point is going to be 121.8. And we know that this maximum height is going to be the y coordinate. And we recall that this 21.8 was found by doing 1.8 plus 20. So we can now relate this to the new model. And we know that this 20 here, it is going to stay the same, but our 1.8 is now going to be 2.1. So therefore the y coordinate of the turning point is going to be equal to 2.1 plus 20. So that means that the maximum height is going to be 20 plus 2.1, which is 22.1 meters. So now taking a look at the second part of question D, we're asked to find the horizontal distance from the archer of the arrow when it's at its maximum height. So we know the equation of our model is 2.1 plus 0.4d minus 0.002d squared. And we know that the maximum height is going to be 22.1 meters. So therefore we can set our equation equal to 22.1. And then we can rearrange this and use the quadratic formula to solve for d. We'll have negative 0.002d squared. Then we'll add 0.4d. And then we'll have 2.1 minus 22.1, which is equal to negative 20. And that's all equal to 0. So we can now use the quadratic formula, and we'll have negative 0.4 plus or minus the square root of 0.4 squared minus 4 lots of negative 0.002 multiplied by negative 20, and we put our square root in, and then we're going to divide all of this by 2 lots of negative 0.002. So therefore, for positive and negative square root, we have that d is going to be equal to 100 in the positive case and also 100 in the negative case. Therefore, we conclude that d is equal to 100 meters. So now we've completed this question, we're going to take a look and see what marks were on offer. So for question part A, there was 3 marks on offer. We received our first mark for setting h equal to 0 and then writing the equation as follows. We then receive our second mark for knowing to use the quadratic formula and substituting all of our values in. And then we receive our third and final mark for concluding with the correct answer. Part B of the question was worth 1 mark, and we received this mark for stating that 1.8 is the initial height of the arrow above the ground. Then moving on to part C of the question, this was worth 3 marks also. We receive our first mark for taking out this common factor of negative 0.002. We then receive the second mark for completing the square, so going from d squared minus 200d down to this term here, d minus 100 squared minus 10,000. We then receive our third mark for coming to the correct conclusion with negative 0.02 d minus 100 squared plus 21.8. And then for part D, there was 2 marks on offer in total. We received our first mark for concluding that the maximum height was 22.1 meters, and then we received our second mark for concluding that the distance was d equals 100 meters. So in this question, there's a controlled experiment where the number of microbes, which is denoted by n, present in a culture t days after the start of the experiment were counted. So here we've got 2 variables. We've got the number of microbes and the time since the start of the experiment. We have the following information: that there's a relationship between the number of microbes and the time t, and that's given by n is equal to at to the power of b, where a and b are both constants. So in part A of this question, we're being asked to show that this relationship can be expressed in the form log 10n is equal to m log 10t plus c, where we give m and c in terms of the constants a and or b. So our starting point for this is going to be here. So we've got our equation n is equal to at to the power of b. So we want to get this n term here into the form log 10n. So what we can do as our first step is take log 10 of both sides. So we'll therefore have log 10 of n is going to be equal to log 10 of this side of the equation also. So that'll be equal to log 10 of at to the power of b. So what we can now do is we can split this up using our log laws. So over here we recall that log of ab is going to be equal to log of a plus log of b. So we'll do that for the next step. So this equation will be equal to log 10 of a plus log 10 of t to the power of b. And then we can then use the second log law we have here, where log of a to the power of m is going to be equal to m log of a. So you can see here we take the power m and move it in front of the log term. So therefore, relating this to our question, our log 10 of a, that will stay the same. And then this term here, we have our exponent b, and that will come down in front of the log 10t. So this leaves us with b log of 10 t. So now we have something that looks similar to what we've been asked for in the question. So we have a term which has log 10 of t with a constant in front. So this b log 10t is equivalent to m log 10t. And then we have log 10 of a, which is our constant term c. So rewriting this once more, we have that log 10 of n is going to be equal to m log 10t, and then we're going to add on c, where we have that m is going to be equal to b, and c is going to be equal to log 10 of a. So now taking a look at part B of this question, we're given a graph which shows the line of best fit for the values of log 10 of n plotted against the values of log 10 of t. So we're asked to use the information provided to estimate the number of microbes present in the culture 3 days after the experiment starts. So essentially the end goal of this question is going to come up with a value of n. And we recall that we were originally given the equation n is equal to at to the power of b. So if we can find out a and find out b, we can then substitute t equals 3 into this equation here to give us the number of microbes. So to get to this stage, we're going to have to work out what a and b are. And we'll do this by taking information off the graph. So recall we have this equation, log 10 of n is equal to m log of 10 t plus c. So we know that c is going to be the y-intercept. So c is going to be the y-intercept, and we know that we can read this off the graph. So looking closely at the graph, we can see that c is equal to around 1.7. And then we recall from the previous question that c was equal to log 10 of a, which means we can work out a by doing 10 to the power of 1.7, which is equal to 50.12. So therefore we've worked out that a is equal to 50.12. And now to find the value of b, so this is the second part we need to be able to work out the number of microbes, we'll do this by working out the gradient. So we know that the gradient is going to be equal to a change in y coordinates over a change in x coordinates. So therefore we can pick out some points in the graph. Let us pick out this point here, which is going to be 1.2 and 4.5. And then if we pick out this point here, which is going to be 0.1 and 1.8. So therefore we can put these numbers into the gradient equation, and we have 4.5 minus 1.8, and we divide this by 1.2, and we subtract 0.1, and putting this into a calculator, this comes out as 2.46. And then from question A, we know that M is going to be equal to B, so that means that B is equal to 2.46. So what we can do now is take our equation for N with these new values for A and B, and if we substitute in T equals 3, we should get the number of microbes present in the culture 3 days after the start of the experiment. So this means we have the following equation. N is going to be equal to 50.12 multiplied by 3 to the power of 2.46. And putting this into our calculator, this comes out as 747.7. And then rounding this to three significant figures, we have 750 microbes. So therefore, we can conclude that after 3 days, there will be around 750 microbes present in the culture. So now for part C of the question. We're asked to explain why the information provided could not reliably be used to estimate the day when the number of microbes in the culture first exceeds 1 million. So for this, we're going to look at the case where N first reaches 1 million. So let N equal 1 million. And then what we can do is we can work out log 10 of N. So we'll do this by taking log of 10 of both sides. So therefore log 10 of N is going to be equal to log 10 of 1 million. And put this into our calculator, we then have that log 10 of 1 million is going to equal 6. So we now take a look at our graph, which we used for part B of the question, and we can see here that our y-axis, log 10n, only goes up to 5. So this value of 6 is out with the data we're given on the graph. So this means we're unable to extrapolate, which means we can't assume this model holds. So therefore the model won't be reliable. So writing this down, we can say that 6 is greater than 5.0, which is out with the data shown on the graph, which means that we can't extrapolate the data, meaning we can't assume that the model still holds. So now for part D of this question, we're asked with reference to the model to interpret the value of the constant A. So we recall the equation we were given initially. N is equal to AT to the power of B. So if we let T equal to 1, so this is going to be the number of microbes present in the culture 1 day after the start of the experiment, we'll then have that N is equal to A1 to the power of B. And we know that 1 to the power of anything is going to be equal to 1. So that implies that N is equal to A. So we therefore can conclude that A is the number of microbes 1 day after the start. So now taking a look back at this question, we're going to see where we picked up our marks. So part A of the question, it was worth 2 marks. We received our first mark for getting to here. So when we had log 10 of A plus log 10 of T of B. So in summary, we're getting our first mark for knowing to use the log laws in the first instance. We then receive our second mark for carrying out the log laws for the second time and then following through to get the correct answer and conclude that M was equal to B and C was equal to log 10 of A, only receiving the second mark for having both M and C. Then moving to part B of the question, there were 4 marks on offer for this part. So we received our first mark for concluding that A was equal to 50.12. We then received our second mark for working through with the gradient and showing that B was equal to 2.46. We've then received our third mark for knowing to substitute 3 into this original equation here, but with our newfound constants A and B. And we then finally get our fourth mark for coming to the correct answer of 750 microbes. And then moving on to part C of this question, there was 2 marks on offer, and we receive our first mark for starting with n equals 1,000,000 and getting to the fact that log 10 of n is then equal to 6. And we then receive our second mark for our reasoning as to why the information provided could not reliably be used to estimate. And we receive our second mark for concluding this and explaining that we can't extrapolate the graph, which means we can't assume that the model still holds. And then finally, for part D of this question, there was 1 mark available, and we received this 1 mark for stating our conclusion, such that A is the number of microbes 1 day after the start of the experiment. So in this question, we're told that the curve C has parametric equations x is equal to 2 cos t and y is equal to root 3 cos 2t, where t is going to be in the range between 0 and pi. So in part A of this question, we're asked to find an expression for dy by dx in terms of t. So what we're going to have to do here is to differentiate with respect to t our x equation and differentiate with respect to t our y equation, and then we can see what we can do with these two equations to give us dy by dx. So let us first note down that x is equal to 2 cos t and that y is equal to root 3 cos 2t. So we can remember the formula for parametric differentiation, where we have that dy by dx is going to be equal to dy by dt, and we multiply this by dt by dx. So what we can now see is if we differentiate our equation for y with respect to t, we'll have dy by dt. And if we differentiate our equation for x, we'll have dx by dt. So then all we need to do is then substitute dy by dt in here. And then we can do 1 over dx by dt to give us dt by dx. So let's calculate these now. So dx by dt is going to be equal to negative 2 sine t, because when we differentiate cos t, it goes to negative sine t. And then our dy by dt is going to be equal to 2 multiplied by root 3 multiplied by negative sine 2t. So here we've used the chain rule to differentiate our 2t, hence why we multiply by 2. Then we have the constant root 3 out in front, and then our cos 2t will differentiate to negative sine 2t, which gives us that dy by dt is going to be equal to negative 2 root 3 sine 2t. So then we recall the double angle formula. So we'll have that sine 2t is going to be equal to 2 sine t cos t. So just bear with this for just now, as this will become clearer as to why we use this in a second. So what we'll now do is we'll take our new equation for dy by dt and for dx by dt and substitute them into this equation here. So we'll then have the dy by dx is going to be equal to negative 2 root 3 sine 2t, and then we'll multiply that by 1 over dx by dt, which is going to be the same as dividing all of this here by negative 2 sine t. So we notice here that the negative 2's will cancel out, And we can then replace sine 2t with 2 sine t cos t. So our equation will then be as follows. We'll have root 3 lots of 2 sine t cos t. And we'll divide this by sine t here. Our denominator doesn't change. And then multiplying out the brackets at the top, we'll have 2 root 3 sine t cos t. And we divide this still by sine of t. And then we now notice that we have a sine t and a sine t here, which will cancel out, which leaves us to conclude that dy by dx is going to be equal to 2 root 3 cos of t. So now moving on to part B of this question, we're given some further information. We're told that the point P lies on C where t is equal to 2 pi over 3, and then we're told that the line L is normal to C at P. And what we're asked to do is show that an equation for L is 2x minus 2 root 3y minus 1 is equal to 0. So effectively what we're being asked to do here is to work out the gradient of the normal and then use that along with the point P, which we can work out using this t value we're given here. And then we use our equation of the line to substitute these values in, and then we can come out with this equation for L. So to begin, we recall that the gradient, so dy by dx, will be given by our answer to part A, which was 2 root 3 cos of t. So now if we substitute in t being equal to 2 pi over 3, we'll have that 2 root 3 cos of 2 pi over 3. And putting this into our calculator, we get that this is negative root 3. Now the gradient of the normal is going to be equal to negative 1 divided by negative root 3, which is equal to 1 over root 3. So therefore we have that the gradient of the normal will be 1 over root 3. And let's denote this by m, as this is normally used for gradient. So the next thing to do is we recall that t is given as 2 pi over 3. And we know from the question that x is equal to 2 cos of t. And y is equal to root 3 cos 2 of t. So what we can now do is we can take this value for t and substitute it into our two equations. And this will give us an x coordinate and a y coordinate. So therefore x is equal to 2 cos 2 pi over 3. And putting that into our calculators, we have that x is equal to negative 1. And likewise for y, we'll have root 3 cos 2 times 2 pi over 3, which again, putting it into our calculator, comes out as negative root 3 divided by 2. So we now have all the ingredients to be able to work out the equation for L. We have our gradient, 1 over root 3, and we have our x coordinate, negative 1, and our y coordinate, negative root 3 over 2. So we'll now use the equation of a line to proceed. So we have y take away negative root 3 divided by 2. And this is going to be equal to m, which is our gradient. So 1 over root 3 multiplied by x minus 1. So then this leaves us with y being equal to 1 over root 3x, and then we multiply 1 over root 3 by 1, so that will give us plus 1 over root 3, and then we subtract root 3 over 2, and then simplifying this, we have y is equal to 1 over root 3 multiplied by x, and then we subtract root 3 divided by 6. So now we'll take a quick look back up the question and see what we're aiming for. So we're aiming for 2x, negative 2 root 3 in front of the y, and then negative 1 as a constant. So we need to think, what can we do to get this into this form? So we need to first get rid of all the denominators here and see what this will do for us. So multiplying everything by root 3, we'll first get that root 3y is equal to x minus 1 over 2. We'll then multiply everything by 2. So just to remind this stage here, we're multiplying by root 3. And then this stage here, we're going to multiply it by 2. So that will then leave us with 2 root 3y is equal to 2x minus 1. So in looking back to our question, this is starting to look very familiar. So we can just rearrange this ever so slightly, and we'll then have that 2x minus 2 root 3y minus 1 is equal to 0. And we've therefore completed the question and found the equation of the line L in the required form. Now taking a look at part C of this question, we're now told that the line L intersects the curve C again at the point Q. So we already know that the line L intersects the curve C at the point P from part B, but we're now told that the line intersects the curve again at the point Q. And what we're being asked to do is to find the exact coordinates of Q. So we're going to quickly recall that x is equal to 2 cos t and y is equal to root 3 cos 2t. And the plan of action here is going to be to substitute x and y into the equation of the line which we solved in part B. So we recall that the equation of line L, and that is going to be 2x minus 2 root 3 multiplied by y minus 1 is equal to 0. So what we'll now do is we'll substitute in x and y into this equation here. So that leaves us with 2 lots of 2 cos of t. Then we're going to subtract 2 root 3 multiplied by root 3 cos of 2t. And then we're going to keep our negative 1 on the end there. So now we'll tidy this up a little bit by expanding the brackets. So 2 multiplied by 2 cos t, that is going to equal to 4 cos t. And then negative 2 root 3 multiplied by root 3, that is going to give us 6. So we'll have negative 6 cos 2t. And then our negative 1 will remain on the end. And that's all still equal to 0. So just to remember, what we're doing now is we're just going to take this equation and solve for t. So recall that 6 cos 2t by the double angle formula is going to equal to 6 lots of 2 cos squared t minus 1, which is going to be equal to 12 cos squared t minus 6. So the reason we want this is then we'll have a quadratic. We'll have a squared term, we'll have a simple t term, and then we'll just have a coefficient there. So we'll now substitute this 12 cos squared t minus 6 back into this equation. So this is going to leave us with 4 cos of t minus 12 cos squared t, and then we have this whole term multiplied by negative, so that will then be plus 6 minus 1 is equal to 0. So we can see here that plus 6, negative 1 is going to be equal to 5, and then to make this slightly easier, what we're going to do is multiply everything by minus 1, so we'll just note that in here, times by minus 1, and that's going to then leave us with 12 cos squared t minus 4 cos of t, and then we have 6 minus 1, which is 5. We then multiply by minus 1, which gives us negative 5, and that's going to be equal to 0. So now we want to let theta equal to cos of t. And it doesn't matter, we could use theta, we could use any letter, but in this case we already have x's, we already have y's, we already have t's, so I think introducing a new variable theta is the best option. So we can then rewrite this equation here, and we'll write it as follows. We'll have 12 theta squared minus 4 theta minus 5, and that's going to be equal to 0. So now what we can do is we can solve for theta, and we'll do this using the quadratic formula. So that then means theta is going to be equal to 4 plus or minus 4 squared minus 4 lots of 12 multiplied by minus 5. Then we remember to square root this term here. Then we're going to divide all of that by 2 times a, and in our case a is 12, so that is going to be 2 times 24. So then putting this into a calculator, we'll have the positive square root will give us that theta is equal to 5 over 6, and then for the negative square root we'll have that theta is equal to negative a half. So then recall that we let theta equal to cos t, so that then means that cos t is equal to 5 over 6, and then also cos t is equal to negative 1 over 2. So then quickly we notice that t is equal to cos negative 1 over 2, and putting this into a calculator, this comes out as 2 pi over 3. But we already know this, so this means that we can ignore this solution. So we'll just write here, ignore solution. So then from here, we can focus on this term here. Cos t is equal to 5 over 6. So let's now look and see what we can do to find the exact coordinates of Q. Remember, we've already ignored the cos of t is equal to negative a half, because this already corresponds to the p coordinate from the previous part of the question. Now we want to find out the coordinate x and the coordinate y. But we already have that x is equal to 2 cos of t, and that y is equal to root 3 cos of 2t. So this means that we can substitute in cos t equals 5 over 6 into this equation here. So we'll have that the x coordinate of Q is going to be equal to 2 multiplied by 5 over 6, which is going to be equal to 10 over 6, which is equal to 5 over 3. We'll have y is going to be equal to root 3 multiplied by cos, and then how do we deal with this 2t? So we know that t is going to be equal to cos negative 1 of 5 over 6. So this means that 2t is going to be equal to 2 times this. So therefore, what we can do is we can replace 2t with cos negative 1, 5 over 6 times 2. And then putting this into a calculator, this comes out as 7 root 3 divided by 18. So therefore, we now have the x coordinates and the y coordinates of our point Q, and we can conclude that Q has the following coordinates: 5 over 3 for the x coordinate, and 7 over 18 root 3 for the y coordinate, and therefore we've completed the question. So in part A of this question, there was 2 marks available, and we received our first mark for getting to this stage here, where dy by dx is equal to negative 2 root 3 sine 2t divided by negative 2 sine t. And then we received our second mark for managing to simplify this down using the double angle formula and concluding that dy by dx is equal to 2 root 3 cos of t. So for part B of this question, we receive our first mark for substituting t is equal to 2 pi over 3 into our equation of the gradient from part 1 to get negative root 3. We then receive our second mark for working out the gradient of the normal and knowing that it is going to be negative 1 over the gradient from the previous part here. So that's our second mark for getting 1 over root 3. We then receive our third mark for working out the coordinates of p. So that was x equals negative 1 and y is equal to negative root 3 over 2. And we do that by substituting 2 pi over 3 into our equations for x and y. We then receive our fourth mark for having the correct form of the normal equation, and this is here, where we have y is equal to 1 over root 3x plus 1 over 3 minus root 3 over 2. And then we receive our fifth mark for working algebraically on this equation here and getting to the required solution of 2x minus 2 root 3y minus 1 is equal to 0. Now for part C of this question, there was 6 marks available. We received our first mark for substituting x equal 2 cos t and y is equal to root 3 cos 2t into our equation of the line from part B of the question. We then received our second mark for using this double angle formula here. We then received our third mark for getting this quadratic here, so 12 cos t squared minus 4 cos t minus 5. We received our third mark for that. We then receive our fourth mark for solving this equation, so we've done it using the quadratic formula, and then concluding that cos t was equal to 5 over 6, and then getting to the fact that cos t was equal to negative a half, and then discarding it due to the fact it was already used from the previous part of the question. That is the point P, so we hence ignore it, and that is how we get our fourth mark. We then get our fifth mark for substituting cos t is equal to 5 over 6 into our equation for x, and then doing the same for y, and we then receive the sixth and final mark for concluding the coordinates of q, and that they are 5 over 3 and 7 over 18 root 3. So in this question we have an equation y is equal to x squared ln x divided by 3 minus 2x plus 5. This is curve C, and part of this is shown here in figure 4. And we can see the parabola-like shape there, and then we have a finite region S, which we can see is shaded here, and that has the lines x equals 1 and x equals 3. So in part A of this question, we're asked to use the trapezium rule with all of these values given in the table to obtain an estimate for the area of S, and we're asked to give our answer to 3 decimal places. We can work out the area using the trapezium rule by doing 1/2 times by h, where h is the width of each bar, and then we're going to have big brackets, and we're going to have y0 plus yn, and then we're going to add this to 2 lots of y1 plus y2 plus all the other y's all the way up to y of n minus 1. Then we close our brackets. So this is the trapezium rule. So there's a few bits of information we need to be able to carry this out. So we need to work out what h is, and then we need to work out y0, yn, and all these other y's along the way. So we'll first look at how to work out h. So as I said, what h is, it is going to be the width of the strips. And we can work this out by looking at the difference between each value of x given in the table. So we can see here we go from 1 to 1.5 to 2 to 2.5 and to 3. So we can see here that each difference is 1 over 2. So we're adding 0.5 each time. So therefore, writing it down potentially more mathematically, we'll have that h is going to be equal to 1.5 minus 1. And it's also going to be equal to 2 minus 1.5, etc. And we know that these all equal 0.5. So therefore we have that the width of each strip is going to be 0.5. Then we have that y0 is going to be this first value of y here. So we'll have y0, then we'll have y1, y2, y3 and y4. So that then means that we can use our formula. Now that we have all the required information, we can say that the area is going to be equal to 1 over 2 multiplied by a half. So writing that in a fraction terms as well, we're going to have 1 over 2. And then we're going to multiply this by 3. And then we're going to add that to y of 4, which is going to be equal to 2.2958. And we'll just put our brackets in just to keep everything straightforward. And then to this we're going to add 2 lots of 2.3041 plus y of 2, which is 1.9242. And then we have y of n minus 1 is going to be y of 3, which is going to be in our case 1.9089. Then we close our big brackets. And then we put all of this into the calculator and we get that the area is equal to 4.39255. So recalling the question, we're asked to do this to 3 decimal places. So we therefore conclude that the area of S is 4.393. And that answers to 3 decimal places. So in question B here, we're asked to explain how the trapezium rule could be used to obtain a more accurate estimate for the area of S. So firstly, what is h? This is going to be useful for this question. So h is the width of the intervals. So we can have a think, what can we do to h to give us a more accurate estimate for the area of S? So when we think about it, when we split our graph up into lots of different strips, we know what we're doing is we split the area into a number of different strips or trapeziums, and then we work out the area of each trapezium, and then that gives us an estimate of the overall area. So what we can do to get a more accurate measurement, we have 2 options. We can decrease the width of the strips. So this means that option 1, it's going to be to decrease h, or in other words, the width of the strips. And when we do this, it means that each strip fits a little bit more area into it, which means that less area is being missed out and the estimate becomes more accurate. And then we have a second option, option 2, and what it's going to be, it is to increase the number of strips. So in theory, if we add in more strips, this is going to give the same effect as decreasing the width of the strips. So just noting that down there, we could also increase the number of strips. And by doing either option 1 or option 2, we will therefore obtain a more accurate estimate for the area of S. So in part C of this question, we're asked to show that the exact area of S can be written in the form a over b plus ln c, where a, b and c are integers to be found. So if we recall back to the earlier part of our question, we were given an equation of curve C, and we'll recall that y was equal to x squared ln x divided by 3, then it subtracted 2x and added on 5. So then from our knowledge of integration, we can then say that the area is going to be equal to the integral of y, which is x squared ln x, and we divide that by 3, then we subtract 2x and add 5. So here you can see our graph on the right hand side of the page, and we can see that the region S goes between x equals 1 and x is equal to 3. So therefore our limits are going to be 3 as the upper limit and 1 as the lower limit. So now we need to have a think and see how we go about integrating this equation. So we know that integrating negative 2x and 5, that's something that we know we're capable of, and it's going to be straightforward to work that through. But then we have the term x squared ln x divided by 3, and this is going to pose us a bit of a difficult challenge, and we'll need to think of a technique that we know to be able to integrate this. We would have options such as integration by substitution, but it will not work in this case, so we have to use integration by parts. And we recall the integration by parts formula. So we'll have that the integral of x squared ln x all divided by 3, and integrating it with respect to x is going to be equal to f of x multiplied by g of x. Then we're going to subtract the integral of f of x multiplied by g dash x, and we integrate this with respect to x. So now what we need to do is we need to assign an f of x and a g of x. So what we're going to do is we're going to let f dash of x be equal to x squared over 3, and then we're going to let g of x be equal to ln of x. So then what we can do is we can work out f of x, and we do that by integrating x squared over 3, and this comes out as x cubed divided by 9. And we can then work out g dash of x by differentiating ln x, which we know is going to be 1 over x. So therefore, we can then do our integration by parts by taking these expressions here and substituting them into our formula for integration by parts here. So therefore, still working with the integral x squared ln x divided by 3 with respect to x, it is going to be equal to x cubed over 9, which is our f of x term, and we're going to multiply that by g of x, which is ln of x. Then we're going to take away the integral of x cubed over 9, and we multiply that by 1 over x, and it's with respect to x. So then our next step here, we can keep the first part of it as is, x cubed over 9 multiplied by ln of x. Then what we see here is we have x cubed over 9, and that has been multiplied by 1 over x, so that is going to be equal to subtracting. We can take out 1 over 9 as it's just a number, and we can scale our integral by it after. And then we still have our integral, and this time we're going to have x cubed divided by x, which is going to be x squared dx. So now we have something we know how to integrate. So we can integrate x squared, and then we have the following. So we'll have x cubed divided by 9, then we'll have ln x, and then we know that this is then going to be negative, then it's going to be 1 over 9 multiplied by x cubed over 3, which is going to come out as x cubed divided by 27. And then just for completeness, we'll add c because we've integrated without a constant. So as you can see, I've now worked out what the integral of x squared ln x over 3 with respect to x is. So this means I can come back to this equation up here and now integrate negative 2x and 5, and then that will mean we've worked out the area. So I'll do this as follows. So therefore, the area is going to be equal to the integral of x squared ln x all divided by 3, and then as we know, we subtract 2x and we add 5, that's with respect to x. So therefore, we have that the area is going to be, so we've just worked out what this integral is in here, so we'll copy this down there. So we're going to have x cubed, we divide that by 9, ln of x, and then we subtract x cubed over 27, and we don't need to add c because we're about to deal with our limits. So we can now take a look at the term negative 2x. So we need to think, what's this going to integrate to? So we know it's going to integrate to negative x squared. And then we have that 5 is going to integrate to 5x with respect to x. So 5x. And then now we've done our integration, we'll put these square brackets in and we'll write down a 3 and a 1 here, as they're still our limits, so we can't forget that. So now what we need to do is substitute in our limits 3 and 1 into this expression for x, and then we can see what the area is. And this is called evaluating a definite integral. So this is going to be equal to, by first taking our upper limit 3 and substituting this in. We're going to have 3 cubed divided by 9, and we multiply this by ln of 3. And then we're going to subtract 3 cubed over 27. And then we subtract 3 squared, which is going to be 9. And then we add 5 times 3, which is 15. Then we'll put our square brackets in here just so we can keep track of things. And then we're going to subtract the same, but with 1 substituted in for x, which is going to give us 1 over 9 ln of 1. And then we're going to take away 1 over 27, and then we'll have subtracted 1 and plus 5. So we can now tidy this up, and what we'll have is, we see that 3 cubed divided by 9 is going to be 27 over 9, which is 3. So we'll have 3 ln 3. And then we subtract 3 cubed over 27. We know that 3 cubed is 27, so 27 over 27 is going to be equal to 1. So we subtract, just write this in here, we'll subtract 1, then we'll subtract 9 and add 15. So putting this into our calculator or doing it in our head, we know that this is going to be equal to 5. So we add 5. And then still being careful with our brackets, we'll then take a look at this second half. So we know that ln of 1 is going to be equal to 0. So therefore, this term here is equal to 0. And then if we take these 3 terms here and add them together, that comes out as 107 divided by 27. So this then means, copying that down here, we'll then subtract 107 over 27. So this then means we'll have that the area of S is going to be equal to 3 ln of 3 plus 28 over 27. And then looking just back to the question to see what we're aiming for, we're asked to write something in the form a over b ln c. But unfortunately so far, we have a constant in front of the ln. We have the following log power law, such that a ln of b is equal to ln b to the power of a. So what we can do here is we can take our 3 here and put it as the exponent of 3, and we know that 3 to the power of 3 is going to be equal to 27. So then that means we can take this one step further and write that a is equal to ln 3 to the power of 3, which is 27, plus 28 over 27. So therefore we can say that a is equal to 28, b is equal to 27, and that c is equal to 27 also. And in conclusion, we then have the exact area of S, and this is written as ln 27 plus 28 over 27. So we'll now take a look back at where the marks were on offer. In part A of the question, there was 3 marks on offer. So we received our first mark for working out that h was equal to 0.5. So this was finding the width of our trapeziums. Our second mark was having the correct form for the trapezium rule. So this means having the equation written out as we have here in the first line. And then the third mark on offer was given for substituting all these values into the right equation and concluding that the area of S using the trapezium rule is 4.393. Then taking a look at question B, we were just given 1 mark for having the correct conclusion. I've included 2 options here, but to receive the mark you only had to include 1. And now taking a look at part C of this question, we received our first mark for knowing to do integration by parts. We then received our second mark for getting the integration by parts into this form here. So x cubed over 9 ln x, take away the integral of x cubed over 9 multiplied by 1 over x. So that's where we got our second mark. We then got our third mark for correctly integrating this and getting to this stage down here. We then receive our fourth mark for doing all the integration correctly and getting to this stage here where we're ready to substitute our limits in. And then we received our fifth mark for correctly substituting these limits in and using these log laws. So knowing to make 3 ln 3 into ln 27. And then we finally receive our sixth and final mark for concluding with the area of S and then stating what A, B and C were. So in this question, we're shown a curve which has the equation y equals f of x, where f of x is equal to 4 sine x over e to the power of root 2 x minus 1. So we're told that the curve has a maximum turning point, which we can see here at P, and we're told it has a minimum point, which we can see here at Q. So now let's take a look and see what this question wants us to do. So for part A of this question, we're asked to show that the x coordinates of point P and point Q are solutions of the equation tan 2x is equal to root 2. So let's get going with this question. So we know f of x, it's 4 sine 2x over e root 2 x minus 1. We know that P and Q are turning points, they're maximums and minimums. So we know that when we have a turning point like that, we know this is called a stationary point. So we then think we have a stationary point, a minimum point, a maximum point. So what should we do here? So what we can say is we will have a stationary point when the derivative of f, so f dash of x, is equal to 0. So in other words, when f dash of x is equal to 0, we're going to have a stationary point. So we now take a look at f of x. So we have something divided by something else. So we know to differentiate this, we want to use the quotient rule. So we recall that the quotient rule to find f dash x is going to be the derivative of the numerator multiplied by the denominator, and then we subtract the numerator multiplied by the derivative of the denominator, and then we divide that by the denominator squared. So just writing all this down, we can do as follows. So let h of x be our numerator, so that's equal to 4 sine 2x, and then let g of x be equal to our denominator, which is e root 2 x minus 1. So then we can work out the derivative of 4 sine 2x. So using the chain rule and our knowledge of trig differentiation, we know that we'll have 2 times 4, so we'll have 8, and then sine goes to cos, so we'll have cos 2x. And then for the derivative of g of x, we will multiply g of x by the derivative of root 2x minus 1. So we know that that differentiates to give root 2. So therefore the derivative of e root 2 x minus 1 is going to be root 2 and then of g of x. So e root 2 x minus 1. So the next stage is to take the quotient rule formula and substitute these values in. So therefore we can write that f dash of x is going to be equal to 8 cos 2x multiplied by e root 2x minus 1. And then we'll subtract h of x, so 4 sine 2 of x multiplied by the derivative of g of x. So that will be root 2 e root 2x minus 1. And then we're going to divide all of this by g of x squared, so e root 2x minus 1, and we square it. So our next step here, we know that to find the stationary point, we'll set f dash x equal to 0. So let's do that just here. So then what we can do next is, if we multiply both sides by the denominator, it will then mean we can clear the denominator because we're multiplying by 0 on this side here. So therefore that leaves us with the following. We're going to have 8 cos 2x multiplied by e root 2x minus 1. And then we subtract. We can do a bit of tidying up here. So we're going to have root 2 multiplied by 4. So that's going to be subtract 4 root 2 sine 2x. And then we'll have our e root 2x minus 1 and set that equal to 0. So now we need to have a think and see what we can do next. So what we notice is that we have a common term between this line here. So we have an exponential term on both sides of our equation. So let's take this out as a common factor. So if we take e root 2x minus 1, let's take that out, and then here we'll multiply by 8 cos 2 of x, and then on this side it'll be 4 root 2 sine 2x, and that's all equal to 0. So if we then now divide both sides by e root 2x minus 1, we'll then eliminate that from this side, and then this side will remain as 0. So we therefore have now that 8 cos 2x minus 4 root 2 sine 2x, and that's still equal to 0. So what we can do now is equate these two terms. So therefore we're going to have 8 cos 2x is going to be equal to 4 root 2 sine 2 of x. So now let's take a look back at our question. So we were wanting to get this into the form tan 2 of x. So we know, one thing that we can note, we know that tan 2 of x is going to be equal to sine 2 of x divided by cos 2 of x. So therefore, we can now manipulate what we have to get it into a form where we have sine x over cos x. So if we now divide both sides by cos 2x, we're going to have that 8 is going to be equal to 4 root 2 sine 2x, and we divide that by cos 2 of x. So then what we can then do is divide both sides by 4 root 2, which gives us that sine 2x over cos 2x is going to be equal to 8 divided by 4 root 2. So therefore tan 2 of x is going to be equal to, we can now simplify 8 over 4 root 2, that simplifies down to root 2, and this gives us the answer that we required to show. Tan 2x is equal to root 2. So now moving on to part B of this question, we're asked to use our answer from part A to find the x-coordinates of the minimum turning point of the curve with the equation. Initially we'll do it for y is equal to f2 of x. So when we had that y was equal to f of x, we had that tan 2 of x was equal to root 2. So therefore, we're now going to have 2 times this. So we can therefore say that for y being equal to f of 2 of x will therefore have that tan, then we multiply 2 by 2, which gives us tan 4 of x is equal to root 2. So then to find the x coordinate, we'll then solve this. So we'll have that x is going to be equal to tan minus 1 of root 2, and we divide by 4. And then in this case, we want to find the second solution, because the first solution will correspond to our maximum turning point. So we therefore add pi over 4. And if we then put this into our calculator, we'll have that x is equal to 1.024. So now for part B of this question, we want to find the minimum turning point on the curve with the equation y is equal to 3 minus 2f of x. So our first thought will be f of x remains unchanged. So therefore, we want to solve tan 2x is equal to root 2. So going ahead and solving this, we'll have that x is going to be equal to tan negative 1 root 2. And since we have 2x, we're going to divide by 2. And putting this into our calculator, we get that this is equal to 0.478. So now you might ask, why did we take the first solution to this? Well, you can see this is a minimum turning point, but then when we scale it and transform the graph by this 3 and negative 2 here, this then changes this into the maximum turning point that we see at point P on the graph. So we'll now take a look back and see where we earned our marks in this question. In part A of the question, there was 4 marks available. We picked up our first mark for attempting to differentiate using the quotient rule or otherwise. So here, when we stated what the quotient rule was, and when we began to show we knew what we were doing with it, we would receive our first mark. We then receive our second mark for getting to this stage here, when we had that f dash x was equal to 8 cos 2x e to root 2 x minus 1, and then we take away 4 sine 2x, multiplying that by root 2 e to the power of root 2 x minus 1 divided by this g of x term squared. That is where we picked up our second mark. We then received our third mark for setting this new f dash x expression. We received our third mark for setting that to be equal to 0. And then we received our fourth mark for doing the algebraic manipulation to then come to the conclusion that tan 2x was equal to 2, which was what the question asked us for. Then moving to part B of the question, it was worth 4 marks in total. So for the first part of the question, we received our first mark for solving tan 4x was equal to 2, and then we receive our second mark for coming to the correct conclusion of x is equal to 1.024, and then similarly for the second part of this question, we receive our first mark for knowing to solve tan 2x is equal to root 2, and then we receive our second mark for coming to the conclusion that x was equal to 0.478.